All right, guys, totally new chapter today. Starting chapter 10, we're going to apply the counting principle and permutations, basically counting stuff, counting choices. So here we go. All right. First of all, the one way to count stuff is using what's called a tree diagram. To be honest, we're not going to do this very much because it's takes up a lot of room, a lot of paper, that kind of stuff. So I do need to show it to you, and you may have to do one, but I'm not going to do too many of these. Problem says a sporting goods store offers 3 types of snowboards, all mountain, freestyle, and carving, and 2 types of boots, soft and hybrid. How many choices does the store offer for snowboarding equipment? So what we did first is we took the 3 options of snowboards, all mountain, freestyle, carving, and you can get any of those in either soft or hybrid, soft or hybrid, soft or hybrid. And basically, it gives you this many choices. It gives you 1, 2, 3, 4, 5, 6 choices. So 6 choices of different kinds of snowboards you can get based on what kind you need. That's called a tree diagram because it basically looks like a tree with branches. So the branches are called branches, obviously, and the tree diagram. Not the best way to count stuff, but it is a way to count stuff. All right, this is the best way. It's called the fundamental counting principle. If you have 2 events, if one event can occur in m ways, another event can occur in n ways, then the number of ways both can occur is m times n. You just multiply your choices. If I'd have done that last time, there were 3 kinds of snowboards and 2 kinds of finishes. 3 times 2 is 6, could have been done. If there's 3 or more, it can be extended and just same deal. If they're all different, now they have to be different events and outcomes, but let's say you have m, n, and p. Number of ways that all 3 can occur, m times n times p. You just have to multiply outcomes. Let me show you one here. This one says you're framing a picture. The frames are available in 12 different sizes. Different styles. Each style is available in 55 different colors. You also want a blue matte board, which is also available in 11 different shades of blue. How many different ways can you frame the picture? How many different ways are there? Imagine doing a tree diagram when you have 55 different colors. That'd be incredible. So what we do instead is what's called the fundamental counting principle. It just says you can just multiply your outcomes. So you have 12 styles, 55 colors, and 11 shades of blue for the matte board. So all you have to do is multiply those. I'm punching it in my calculator right now. 12 times 55 times 11. 7,260 different ways you could frame that picture. Craziness, who would have thought? But mainly because there's 55 different colors. All right, the standard configuration for a Texas license plate is 1 letter followed by 2 digits followed by 3 letters. So it's a letter, it goes like this: a letter, digit, digit, letter, letter, letter. That's how a Texas license plate looks. There are 26 letters in the alphabet. There are 10 digits because you have to count 0. So 0 through 9 is 10 digits, just like on your cell phone. Okay. Part A, how many different license plates are possible if letters and digits can be repeated? So what I do a lot of times is I'm going to draw blanks for each spot. So I have a letter, a digit, a letter, a letter, a letter. Now, for my first blank, I have 26 choices of how many letters I could choose from. My first digit, I have 9 choices of how many, sorry, that's not right. I have 10 digits to choose from because there are 10 digits, or what I was thinking, 0 through 9. Because it says I can repeating is allowed, I also have 10 choices for the next digit because I could use like 7 twice in a row. And because I can repeat, I have 26 more choices for that letter, 26 for that letter, 26 for that letter. That's a lot of license plate, but you know what? Texas needs a lot of license plates. So I'm punching that in right now. I'm really punching in 26 to the 4th power times 100 because that's what 10 times 10 is. Oh my goodness, this is how many license plates are possible. 4, 5, 6, 9, 7, 6, 0, 0. Put your commas in there. 45 million license plates if you can repeat digits. That's a lot. That's enough for Texas probably. Part B, how many different license plates are possible if you cannot repeat? So watch what I'm going to do now. Still the same configuration. Letter, digit, digit, letter, letter, letter. But a couple things change because I cannot repeat this time. So whatever I still have 26 letters to choose from there, still have 10 digits to choose from there, but because I've already used 1 digit, I only have 9 to choose from for there. And because I've used 1 letter already, I only have 25 choices, and then I've used 2 letters, so I have 24 choices. Now I've used 3 letters, so I only have 23 choices. So I'm going to multiply that out real quick on the calculator and get it's still going to be a large number, but much smaller because I can't repeat. So 322,920,000. So that one is 32 million. So I get 13 more million license plates because you can repeat. And again, you're going to see me draw blanks like that a lot and just fill them in with numbers that are missing. That's also a fundamental counting principle. Okay, a special kind of counting is called permutations. Permutations are when you count an ordering of n objects. Let's say I have A, B, and C, those letters A, B, and C, for example. If I want to count how many different ways I can order those letters, well, let's see, I could do A, C, B. I could put B in the front, go B, A, C. I could do B, C, A. I could put C in the front, go C, A, B, C, B, A. That's all. So there's 6 different ways. Well, there's another word called factorial, which is a great way to do permutations or count orders. And all you have to do is this: how many objects there are. If there's n objects, you can do 3 factorial. Factorial has an exclamation point. You don't say 3. It's just the way you work out a factorial is you go 3 times 2 times 1. And your calculator has a factorial button. If you go to your calculator, hit your math button, and then go to PROB on the top, you will see an exclamation point. And that's 6, which is the same number I found up there. So the number of permutations of n distinct objects, if you arrange all of them or order all of them, it's n factorial. Let me show you something cool. You may not think this is cool. In my classroom, we have 9 seats in the front row. So if I just took the number of people in my front row and figured out how many different ways I could arrange them or order them just for a seating chart, just a front row only, I would do 9 factorial. 9 factorial is this. That is crazy. That means I have 362,880 ways I can arrange just my front row. Just you people who sit in the front row. That's the number of different seating charts I have, not even including the back row or those people. Front row only. Okay, let's see if we can try some factorial stuff here. 2 teams are competing in the final round of the Olympic 4-person bobsledding competition, Part A. And how many different ways can the bobsledding teams finish the competition? Okay, that's all the teams. How many different orders can they finish? Well, that's a permutation. That's because it'd be 10 teams have a choice for the first spot, and then you have 9 teams left, then 8 teams left to finish, then 7 teams left. So it's just 10 factorial. So I'm punching that in, go to 10, hit math, PROB, find your exclamation point, and I think I messed up my last slide. No, I didn't. 8800. So that's close to what I had a minute ago, but there's 3 million different ways that those teams can finish, which is also crazy when you think about it. Okay, Part B. In how many ways can 3 of the bobsledding teams finish first, second, third to win that one? Now to do that, I'm going back to what I did a minute ago. How many choices of teams can have? How many possible teams can come in first? 10 can. All right, but after 1 comes in first, only 9 teams have a chance to come in second. And after you have first and second, only 8 teams have a chance to come in third. So I'm just going to do 10 times 9 times 8, and I get 720. So 720 different ways that they can finish first, second, third. Okay. One way to do the problem I just did is permutations taken R at a time. So all we've talked about so far with permutations is arranging or ordering all of them. Right, like 3 factorial, 9 factorial, arranging everything we had. It also is a way to count permutations, just taking a few of those objects, and we're going to do this right here. You do n factorial over n minus r factorial, where n is the total number of objects there are, and r is how many you're arranging. We're actually going to use our calculator button to figure out the NPR, but that's what those letters, you need to know what the letters mean. One more time, n is the total number, it's going to be the big number. R is how many you're arranging or ordering out of that number. Okay, here's a quick example. Says you were burning a CD demo for your band. Your band has 12 songs stored in your computer. However, you want to put only 4 songs on the demo CD. And how many orders can you burn 4 of the 12 songs to the CD? So you're not putting all the songs on there, just 4. So it's asking how many different orders can you put those in, those 4 songs out of 12. So that was set up like this, 12P4. Okay, where 12 is the total number, 4 is how many you're arranging. Now, on your calculator, wrong button. On your calculator, I just showed my final answer here, but if you go to your math button, right under your alpha button, and go to PROB on the top, you will find the little P. You'll find the NPR button there. You can just punch in 12 and 4 with it, and you get 11,000 880, and that's going to be your answer. And I will show you that in class tomorrow, exactly where that button is, how to use it. It's easier live than it is on a video, so I will show you that in class tomorrow for sure. Okay, and again, they're going to make you practice on your calculator tomorrow. So it's this, like the first one says 5P3, the second one says 4P1. I just took a picture of how I did that on the calculator, or at least what your final answer is going to look like. Again, it's in math. I'll write it down right here. You go to math, the math button. Once you're there, you look at the top row and go to PROB. And as soon as you get there, when you go to math and you go to I'm going to right now to make sure I get the number right. PROB, if you look at number 2, you're going to see this button. You're going to see NPR. And then you just come back to your main menu and put your numbers in. No big deal. Very simple. Nice button to have, though. All right, permutations with repetition. One thing we haven't talked about is what happens if something repeats. Like what if you're arranging letters but from a word, but some of the letters repeat? And the way we're going to do that is we're going to take the total number of letters or whatever the object is on top in my numerator. My denominator is going to be everything that repeats, factorial, right? So S1 factorial, S2 factorial, all multiplied together. And again, those are the things that repeat. And not only that, but how many times they repeat. It's kind of hard to explain without showing you one. I got one more slide here. Let me show you exactly what I'm talking about. All right, this one says find the number of distinguishable permutations of the letters in the word Tennessee. Tennessee is a great word for lots of reasons, but if you're going to arrange all those letters in different ways, you got to understand if I were to move those two N's, if I just switch those two, you would never know. It would still say Tennessee. If I move the two S's, it would still say Tennessee. So it's a problem counting orders because things repeat. So here's the rule for how we do that. You count the total number of letters in Tennessee, which is 9. So I'm going to put 9 factorial in my numerator. In my denominator, I'm going to count everything that repeats. And what I'm going to do is I'm going to put the number in my denominator of the times it repeats. For example, there are 4 E's, so I'm going to go 4 factorial. There are 2 N's, so I'm going 2 factorial. There are 2 S's, so I'm going 2 factorial. And that's all the stuff that repeats, the N's and S's and E's. So to find out how many different ways you can arrange the letters in Tennessee, that's what you would punch in. Now, I have a picture here of me punching that in. And that's how I punched it in. And notice my denominator is in parentheses because there's more than one number down there. And if you don't do that, your calculator will give you an answer, but it'll be really wrong. Make sure you put your denominator in parentheses. And there's your answer, 3,780. That might be a good homework assignment. Bring in all 3,780 arrangements of the word Tennessee. Might be a good problem to do. Just kidding. We won't do that. But, who knows. So anyway, a lot of stuff today, permutations, factorials, fundamental counting principle. Really different from anything we've done so far this year, but I think you're going to like it as we get going into it. So I'll see you tomorrow and we'll work on it.